Welcome to my session. My name is P. Harshit. Today, I am going to tell a seminar on the topic operations of signals from the subject signals and systems. Now, let's discuss the basic definition. What is meant by operations on signals? A signal operation is an action performed on a signal. It may be continuous or discrete to change its properties or extract useful information. So we may have a signal, some x of t, but that particular signal x of t is not favorable to us, means it is occurring early, or the strength of the signal is not enough to us, or the amplitude frequency are not favorable to us, but it is the signal what we want. Then we are going to use these operations on signals to make it favorable for us. Now let's discuss each one of them and how to use it. Here's our first operation, that is time shifting. So what is time shifting? Let's discuss definition. Time shifting means shifting a signal in time either forward or backward. Here, forward or backward means making the signal advance or delay. Delay also means by lagging. Now let's discuss the formula, how to do it. If the original signal is x of t, the time shifted signal is x of t minus t naught. Here, t naught is the constant by which factor we want to shift the time, either by forward or backward. That means either advance or by the delay. Example here given, if x of t naught greater than 0, then signal shifts to the right side, that is delay. If t naught is less than 0, the signal left side. That means the signal is occurring in the advance. Means the signal is getting advanced. Next, here from the diagram, let's discuss time shifting. F of t, by doing time shifting, we are getting f of t minus a. Here, a is the factor by which we are going to shift the time. From the point we discussed previously here, f of t minus a means the signal is going to the lag or delay. And next, f of t is equal to t plus a, means the signal is going a units of the number or constant a to the left side. That means the signal is occurring advance. Now let's discuss the another operation on which we apply on signals, that is time scaling. Now let's discuss the definition. Definition for time scaling is compressing or expanding a signal along the time axis. For example, we have a signal, but we want its frequency to be increased or decreased, or we want it is a periodic signal and we want to make its periodicity increase or to decrease. Then we are going to use this time scaling formula, x of at. Here, let's think x of t is the signal we want, and by doing scaling, we are going to multiply a constant a to the inside of the function. So we get x of at. Here the conditions are given. If a greater than 1, signal is compressed. If a greater than 0 but less than 1, then the signal is said to be expanded. As it gets to the fractional part, the signal automatically gets expanded. Next operation is the time reversal or reflection. So what is time reversal or reflection? Flipping the signal along the time axis. Now let's discuss this topic through the diagram. Time reversal. When A is equal to -1, in this case of folding the signal along the y-axis. Suppose we have a signal x of t, we are going to substitute for every value of t a negative value of t, that is a minus t. This will flip the graph or the equation with respect to the y-axis to the left side. This will cause an exact mirror image of the signal with respect to the y-axis. Formula x of minus t, where x of t is the signal we wanted. On substituting minus t, we get x of minus t, which is the exact reflection of the signal which we wanted. Amplitude scaling. This is the other operation we are going to do on signals. So let's discuss the basic definition. What is amplitude scaling? Changing the amplitude of the signal by multiplying by a constant. For suppose we have a signal, say some y of t, but we do not have an enough amplitude or enough range in the y-axis. So we cannot get the enough energy for the signal. In that case, we are going to use the amplitude scaling, which is a far different from the time scaling. In the amplitude scaling, we are going to multiply the function with constant a from outwards. Meanwhile, in the time scaling, we are going to multiply the constant a within the function. We can see clearly this in the diagram. Now let's see. A into x of t. If a greater than 1, then the amplitude increases. If 0 greater than a and less than 1, the amplitude decreases as it will be going through the fractional part. Now let's discuss the another operation. Signal addition. Definition. Addition of two signals together pointwise. We have, for suppose, let's explain through the example. x1 of t and x2 of t. x1 of t can be defined as minus x is equal to -1 to 3, defined as for a value y is equal to 1, and x2 of t defined for values x is equal to 0 to 2 and y value is 2. Now, when we are going to add two signals, here we can see the formula. Y of t is equal to x of t plus w of t. X of t here is equal to x1 of t. W of t is equal to x2 of t. Now let's take according to the equations. Now let's take according to the interval. For x1 of t, -1 to 0 is an interval. Now let's take for x2 of t, -1 to 0, the value is 0. And for x1 of t, -1 to 0, the value is 1. On adding both, we get for -1 to 0, addition of both signals, we are going to get a value of 1. And the next breakage is to 0 to 2. For x1 of t, 0 to 2, the y value is going to be 1. For x2 of t, for x values 0 to 2, the y value is going to be 2. And for addition, 2 plus 1, that means x1 of t plus x2 of t for that particular interval, we're going to get the value 3. And same for the interval 2 and 3, x1 of t, the value is 1, y1 of t, x2 of t, the value is 0. By adding both signals, we get the value x1 of t plus x2 of t is equal to 1. Hence, the bottommost figure is obtained through the signal addition. Like this, we are going to perform signal addition. The next operation which we are going to discuss is signal multiplication or modulation. This is quite similar to the signal addition which we have already discussed in the previous slide. Now let's discuss the basic definition of what is signal multiplication. Definition: multiplying two signals pointwise. Means, for suppose the same process we are gonna do here also, but we are just gonna multiply. Okay. Now, before going to the example, let's see the formula. Y of t is equal to x of t into w of t. where x of t and w of t are the signals which I want to multiply. Here I am naming them as x1 of t and x2 of t. For x1 of t, for the interval -1 to 0, the y value is 3. And for x2 of 3, -1 to 0, the value is 2, 0. And multiplying on both, we get the value 0. And for the interval 0 to 2, the x2 of t value is 2. And for the interval 0 to 2, the x1 of t value is 3. And on multiplying for this in that interval is equal to 6. For y of t is equal to 0 to 2. And the next interval we are going to take is 2 to 3. For x1 of t, 2 to 3 interval tends to the value 3. And for x2 of t, 2 to 3 is the value 0, as there is no energy given in the diagram. So on multiplying the 3 and 0, we get the value 0. So for the answer y of t, we get for the interval 0 to 2 to 3, we get the value 0. Like this, the signal multiplication or modulation works. Differentiation or the derivative of a signal measures the rate of change of a signal. Suppose there is a signal which varies with respect to time, but I want to find the particular value for which it changes at a rate. The signal changes for each time at a different rate, but I want to find the rate at which it changes at a particular time. So then we are going to use this operation, that is the differentiation or the derivative of a signal. Here the operation is given. The operation is y of t is equal to dx of t by dt. That means differentiating x of t with respect to dt. So let's discuss why it is important. Important in control systems to study the dynamic behavior. Integration of a signal. So what is the integration of a signal? It is quite different or exactly opposite to the derivation of a signal. In the derivation of a differentiation of a signal, we are going to get the overall signal and we want to find the rate of change at a particular part. But in the integration of a signal, we know the rate integration of a signal, we know the graph x of t, and we want to find the area under the graph for various calculations. So let's discuss how we are going to find it. Measures the accumulated area under the signal curve. Operation y of t is equal to integral x of tau d tau. What it is used for? Helps in filtering and signal smoothing. Convolution. What is convolution? This is a very important topic. Convolution is a way of combining two signals to form a third signal. In continuous time system, the convolution works as follows. Y of t is equal to x convolution h of t is equal to integration of -infinity to infinity of tau h of t minus tau d tau. The convolution we can simply define as the common area or the common equation which the given equation gonna act for the common. So we have discussed how it is going to work in the continuous time. Now we are going to discuss how it is going to work in the discrete time. Here's the discrete time format. Y of n is equal to x star x convolution n. For discrete, we are going to use the square brackets and we are going to use the summation. Here's how we can do it. Summation of k is equal to -infinity to infinity only for discrete values, and x of k h of n minus k we are going to do for discrete values. Here k is the random we're gonna substitute for our answer. N minus k, we're gonna do substitution, and for the previous slide also. Here, x of t is equal to the input signal, h of t or h of n is equal to system impulse, and y of t or y of n is the output signal. Thank you. That is my seminar. Bye.